You think you understand reality. You think you see the world as it is. You imagine particles moving, colliding, bouncing like tiny billiard balls. You picture atoms as tiny solid spheres, electrons circling neatly around a nucleus, following predictable paths. You believe in cause and effect. You believe in certainty. You believe in things and positions and moments. You are wrong. Every instinct you have, every mental image you hold is misleading you. The world you think you touch, see, and measure, it doesn't exist that way at all. Reality is stranger than your senses can comprehend. It's stranger than your mind can hold. And yet, somehow, it obeys rules. Rules that don't care about what you think is real. Everything you know about motion, position, and certainty, it begins to unravel here. You think a particle is like a tiny, solid ball. You imagine it moving through space along a definite path, just like a marble rolling across a table. You picture it bouncing, colliding, obeying simple rules. You believe that if you knew enough its position, its speed, you could predict exactly where it will be tomorrow, next week, next year. This is the intuition everyone carries, even without realizing it. It is comfortable. It feels right. It feels real. But it is wrong. Start with something simple, an electron. You might imagine it orbiting a nucleus like a planet around the sun. You picture its path, its speed, its location at any moment. You want to imagine a dot tracing a curve through space. But here's the problem: electrons do not follow these paths. They do not sit somewhere definite until you try to measure them. Before measurement, asking where is it is not just difficult, it is meaningless. The electron is not in one place. It is everywhere it can be, all at once, described only by a mathematical cloud of probabilities. Think about what this does to certainty. You might have believed the world is a series of definite events, like dominoes falling predictably in a line. But quantum mechanics tells a different story. It says that at its core, reality is a fog. There is no hidden path, no secret roadmap. Particles don't hide from us. They simply do not have definite positions to hide in. Position, velocity, momentum, all of these things are concepts that apply only after interaction, only after measurement. You feel uncomfortable. You feel something slipping. That is exactly the point. Quantum mechanics does not respect the intuition honed by centuries of watching billiard balls, tossing baseballs, or walking through a room. Those instincts work perfectly for large objects, but they betray you when applied to the microscopic world. You are not failing physics. Physics is failing your intuition. Even worse, this is not just about electrons or atoms. It applies to everything: photons, quarks, neutrons, the entire foundation of matter, the very stuff you think exists solidly beneath your fingers is fundamentally uncertain. Solid matter is an illusion maintained by the collective behavior of countless quantum particles, each individually defying certainty. So the next time you reach out to touch something, remember this: nothing is where you think it is. Not until you measure, not until reality forces an answer. Until then, the world is a haze of possibility, a fog of probability, a place where your most basic intuitions, position, path, predictability, simply do not hold. You were certain. You were wrong. You think particles are solid. You imagine them as tiny marbles, points in space, moving along neat trajectories. You picture an electron as a tiny sphere orbiting a nucleus, a dot tracing a single path. But that picture is wrong, completely wrong. Imagine tossing a pebble into a pond. Ripples spread in circles, overlapping, interfering. Now imagine an electron doing the same thing, but through empty space, without water, without a pond. Strange, isn't it? The electron behaves as if it is a wave, a spread out disturbance, not a localized dot. It does just travel from point A to point B. It explores every possible path simultaneously. Its presence is smeared out, a haze of probability, an extended pattern that can bend, interfere, and cancel itself out. The famous double-slit experiment makes this undeniable. You send electrons one at a time toward two narrow slits. You might expect two neat clumps on the screen behind, corresponding to each slit. But what appears instead is a full interference pattern, stripes of high and low intensity, exactly like waves overlapping in water. Every electron contributes to the whole, as if it went through both slits at once. Pause and consider what this does to your mental picture. If you insist on thinking of electrons as tiny balls, you are lost. A ball cannot go through two slits simultaneously. A ball cannot interfere with itself, yet the electron does. The world refuses your simplest analogy. Solid, indivisible things dissolve into patterns of probability, extended and overlapping, guided by something you cannot see. This is not metaphor. It is literal. Electrons, photons, atoms, they are waves. Their position is undefined. Their paths are undefined. Only the wave, the spread out possibility, is real. And it is this wave that determines where the particle might be found if you try to measure it. The act of measurement collapses the wave into one of many possibilities, but until that moment it is everywhere, nowhere, both neither. Think about motion. You imagine motion as a point traveling along a line. Waves done, move like that. They spread, they interfere, they resonate. The particle you thought was moving is actually a manifestation of a wave, a probability cloud, collapsing only when forced to answer. Motion in the quantum world is not continuous, not predictable, not certain. It is a pattern unfolding in a fog of possibility. And yet, despite all this, you see particles appear to behave as solid objects in everyday life. That is the deception. Waves become particles. Only when interacting with other systems, when measured, when constrained, your intuition, born from macroscopic experience, insists on discrete dots. But the deeper truth, the quantum truth, is wave first, particle second. And your comfortable mental image, once again, is inadequate. You think you see a particle. You do not. You see only the shadow of a wave. You think the universe is predictable. You imagine that if you could measure everything, position, speed, angle, you could calculate the future with certainty. You think reality obeys a clockwork logic, a chain of cause and effect so precise that nothing is left to chance. That is the classical worldview. That is the world you trust. But it is wrong. In quantum mechanics, certainty does not exist, not even in principle. An electron approaching a screen does not have a definite outcome. It does not choose a spot in a deterministic way. Instead, it has a range of possible outcomes, each with a specific probability. The electron's path is a landscape of likelihoods, a map of maybe here and maybe there, but no absolute here until measured. Probability is not just ignorance. It is not that we lack information, as in classical uncertainty. In the quantum world, there is no hidden information. The electron's behavior is genuinely random. Nature does not allow you to predict the next event with absolute certainty. All you can do is assign probabilities and watch the pattern emerge statistically. Consider the decay of a single radioactive atom. You can calculate the half-life of 1,000,000 atoms with incredible precision, but predicting exactly when a single atom will decay is impossible. The atom does not have a secret clock ticking down to the moment of decay. It is a fundamental property of the universe. Randomness is built in. Now, take the double-slit experiment again. Each electron lands seemingly at random on the detection screen. Yet, over time, a clear interference pattern emerges. Individual events are unpredictable, but the statistical structure is perfect. Probability governs not just our knowledge, but the very behavior of matter itself. Chaos is not merely epistemological, it is ontological. This appends every intuition you have about cause and effect. You might think if only you knew enough you could anticipate outcomes. But quantum mechanics insists otherwise. The rules are probabilistic, not deterministic. The world does not unfold like clockwork. It unfolds like a dance of possibilities, and your classical instincts, your desire for certainty fail at every step. Even your notion of law changes. Classical laws predict what will happen. Quantum laws predict what might happen with precise probabilities. There is a logic to chance, a pattern to randomness, but it is not the logic you learned in high school physics. The universe is a probabilistic landscape, not a sequence of fixed events. So every time you think, if I only knew enough, I could predict it. Remember this, in the quantum world, that thought is meaningless. The universe does not care about your predictions. It only cares about probabilities. And probability, not certainty, is the true rule of reality. You think the world exists independently of you. You imagine that objects have definite properties, whether or not anyone looks at them. You believe the universe is out there, waiting quietly for you to notice it. That is classical intuition. That is what every sense and every habit reinforces. But it is wrong. In quantum mechanics, the act of observation is not passive. It is not a mere recording of pre-existing facts. Measurement changes the system. When you try to locate an electron, you uncover a hidden position, you force it into one of many possible states. Reality at the quantum level is not fixed until you interact with it. Consider the simplest thought experiment, an electron in a cloud of possibilities. Before measurement, it is spread out, existing in multiple locations simultaneously. You cannot say it is here or there or anywhere in particular. The question itself has no answer. Only when you measure, only when you interact with it does the electron choose a location. Observation collapses the possibilities into a single reality. This is not metaphor. This is literal. The electron does not passively wait. Your very act of probing changes it. You are not a detached observer. You are part of the system. You cannot separate yourself from the reality you seek to measure. Reality in the quantum world is participatory. Now consider interference experiments. Send electrons through a double-slit apparatus without detecting which slit they pass through. They create an interference pattern behaving like waves. Detect which slit they go through, even gently, and the interference disappears. Just the act of measurement changes the behavior of reality itself. The world you observe is not the same as the world that exists unobserved. This idea shakes every classical belief. You cannot assume that objects exist in a definite state independent of interaction. You cannot treat measurement as passive. The universe is not a stage where events unfold independently of the audience. At the quantum level, there is no stage, no audience, no separation. There is only interaction, and reality emerges through that interaction. Even stranger, this is not limited to tiny particles. Entanglement shows that observation here can affect outcomes there instantaneously across distance. The universe is more interconnected than your intuition allows. Observation is not a window, it is a tool, a mechanism that shapes what you call a reality. So every time you think, things are what they are, whether I look or not. Remember this, at the quantum scale, that thought is false. Your act of observing is part of the creation of the world. You are not outside reality. You are entwined with it. You think objects have a single, definite state. You imagine an electron is either here or there, spinning one way or the other, carrying one property at a time. You assume influence is local, that nothing can affect something far away instantly. These are intuitions born from a world of everyday objects. But they are wrong. Quantum mechanics introduces a radical idea, superposition. A particle can exist in multiple states simultaneously. An electron is not up or down, not here or there. It is both, neither, and every combination in between. Its state is a cloud of possibilities, each coexisting until measured. Only when forced to reveal itself does one possibility become reality. Think of Schrödinger's famous cat. The cat is not alive or dead in isolation. It is both suspended in superposition until a box is opened. This is not just a thought experiment. At the quantum level, it is literal. Particles are waves of probability, existing in overlapping, coexisting states that defy any classical description. Now consider entanglement. Two particles are created together in a single quantum state. Measure one, and the state of the other is instantly determined, no matter the distance separating them. Einstein called this spooky action at a distance, but it happens and repeatedly. The universe does not restrict influence to nearby objects. Connection can be instantaneous, non-local, and absolute. This destroys the most basic intuitions. You assume separateness. You assume locality. You assume that the properties of one particle cannot depend on the state of another far away. Quantum mechanics proves this is false. Reality at its deepest level is relational. Properties exist not in isolation but as correlations. Objects are not independent. They are entwined in ways that your mind struggles to grasp. Superposition and entanglement force you to abandon certainty and locality simultaneously. One particle embodies multiple realities. Two entangled particles defy distance, instantaneously shaping each other. Classical ideas of here and there, of one thing and another, are insufficient. They collapse under the weight of quantum truth. Even more, this is not just theoretical. Experiments repeatedly confirm these effects. Bell inequalities, photon polarization studies, entangled electrons all demonstrate that reality is fundamentally interconnected, probabilistic, and unfixed until observed. So when you picture the world as composed of independent objects, each with a single state, remember this, you are imagining a dream. At the quantum level, particles live in multiple states at once, and their fates can be inseparably linked no matter how far apart. Reality is stranger, more fluid, and more entangled than you ever thought possible. You think reality follows the logic you learned in school. You assume that statements about the world are either true or false. You imagine that an object either has a property or it does. Classical logic seems unshakable, a framework that governs not just thought but reality itself. But in the quantum world, that logic fails. Particles do not obey yes or no rules. An electron is not simply here or there, up or down. It can exist in a superposition of states, a combination of possibilities that defies classical reasoning. The rules you use to reason about everyday objects, laws of identity, non-contradiction, and excluded middle simply do not apply. In quantum mechanics, a particle can behave as if contradictory states coexist until measurement forces a single outcome. Consider again the double-slit experiment. You might ask, did the electron go through slit A or slit B? Classical logic demands an answer. The electron cannot do both. Yet the interference pattern tells a different story. It went through both in a sense that cannot be described with classical truth values. Only quantum logic probabilities, amplitudes, wave functions captures the behavior. This logic is not abstract, mathematics detached from reality. It is reality. The equations of quantum mechanics are not merely predictive. They describe how reality operates at the level where classical intuition fails. The weirdness of superposition, entanglement, and uncertainty is not a flaw in the theory. It is a feature of the word itself. Probability replaces certainty. Wave functions replace definite positions. Observables are not absolute but relational. The universe obeys rules. Yes, but rules that are unlike anything you experience in daily life. Logic is not abandoned, it is transformed. Classical logic applies only as an approximation, emerging from the collective behavior of countless quantum systems, not at the level of the particle itself. Philosophically, this is profound. You thought reality was something you could dissect with clear yes or no statements. Instead, the microscopic world is a landscape of possibilities, a network of correlations, a logic where truth is contextual, probabilistic, and fundamentally uncertain. The laws of quantum mechanics are a guide to thinking differently, to letting go of familiar mental crutches, to accepting that the universe does not conform to human expectations. So every time you reason about the world, remember this, classical logic is not universal. It is emergent. At the deepest level, reality is governed by a different kind of order, one that makes sense only when you abandon certainty, embrace probability, and accept that the universe is more abstract and stranger than your mind naturally allows. You think the universe is orderly, predictable, and safe to comprehend. You imagine that reality conforms to your experience, that matter is solid, that cause follows effect, that the world is understandable in familiar terms. That belief gives comfort. That belief gives meaning, but it is wrong. Quantum mechanics strips away that comfort. It reveals a universe where certainty is impossible, where particles exist in multiple states at once, where measurement shapes reality, and where distant objects can instantaneously influence each other. The world is not what you feel with your senses, not what you imagine in your mind. The solidity beneath your fingers, the stability around you, is a construct emerging from countless interactions of fundamentally uncertain, interconnected particles. Consider your intuition about space and time. You picture an electron tracing a path through a well-defined trajectory, moving step by step along a line, obeying cause and effect. In truth, it explores countless paths simultaneously, a superposition of possibilities, and only reveals a single outcome when forced by observation. Reality is not a line, it is a cloud, and you're always entering it halfway through. Think about entanglement. Two particles created together, separated by miles, instantaneously correlate their states. You believe that influence is local, that nothing can travel faster than light. Quantum mechanics says otherwise. It says that connections exist beyond your classical notions of space, beyond your intuitive map of the world. Cause and effect here and there become questions without absolute answers. Even probability, which might seem comforting, is stranger than expected. The universe is not secretly deterministic. Randomness is not ignorance. It is fundamental. Nature is inherently uncertain, and no amount of observation or calculation can circumvent that. Every prediction, every expectation, every plan meets the limit of quantum reality. Philosophically, this is disorienting. You cannot fully trust your senses, your logic, or your intuitions. You cannot assume the universe will behave as it does in your everyday experience. And yet this very strangeness is beautiful. It is a world richer than your imagination, a universe more subtle, more intricate, and more profound than the simple clockwork you once believed in. Reality without comfort is reality without boundaries. It is unpredictable, entangled, probabilistic, and wondrous. It is a universe that does not exist for you, that does not accommodate your expectations, but that obeys laws stranger and more elegant than your mind can hold. And in the quiet space, where certainty dissolves, where classical images fail, and where intuition is betrayed, a new kind of awe emerges, not comfort, not explanation, but the breathtaking recognition that the universe is more mysterious, more intricate, and more alive than you ever imagined.